Okay, I'm back. Sorry about that. So here's our problem. We have no way to create a Python project from scratch and then use a Nix Flake to manage all dependencies, building, etc. We're going to nix a Python project. The first thing we want to do is we really just want to set up a Python project, and we're going to use Poetry to do that. It's just a package manager and packaging system for Python. If you've ever used pip, this essentially replaces it. To basically use Poetry, you install it, which I've already got it installed, and then you do Poetry new, Poetry demo. So we're going to say Poetry new example Nix Python. So if you notice, it says created package example Nix Python in example Nix Python. So we now have a package in example Nix Python, our directory. And if we go in here, you can see like it already fills it out with a bunch of stuff, my name, my email. And then we're going to say this is a example Python project built with Nix. So what does this mean? So this means that right now I just have a Python project. If I wanted to, if I said Poetry install, it's going to take whatever dependencies I currently have, and it's going to, as you'll notice, create a Poetry virtual env. We've got our packages installed. This also generates a poetry.lock. This is important for the nixing part. When we talk about Nix, Nix is meant to be focused on reproducibility. And one of the biggest ways that it does achieve reproducibility is utilizing things like this, lock files. What it does is it takes your package dependencies and it pins them to the versions that you are expecting them to install. Now, if you look, you'll see that it's actually using semver because it's doing different types of targeting. So this lock gives us a lot of metadata essentially on the packages that are to be installed. My main point of talking about that is just simply that Nix is going to use them. I wouldn't be able to start Nixifying this project really until I had a lock file, at least with regards to what I'm trying to do with Python. I do want to actually set this project up so that I can kind of run something and have it work. What we want to do is we want to declare it as a script in the project py.yaml. Okay, cool. Yeah, let's do that. So let's go here. We want this tool Poetry scripts and then my package. So my package in this case would be example Nix Python. So in this case, maybe we just create like main.py. We'll say main. I think we'd go to like main def start print hello chat. That's how you do hello worlds on Twitch, by the way. You do hello chats. So we've got this. So now how do I run this command, my script? So let's call this start. So then let's do poetry run start. Hey, cool. Okay. So now what we're going to do is we're going to set up Nix. Let's do this. We're going to use the code that Cran was nice enough to write up for us. Now this is going to enable us to create a very, very, very simple reproducible package of our Python package that we've made. So I'm going to say touch flake.nix. Cool. There's my flake. And we're going to go ahead and open it up. A flake is consisted of essentially inputs, outputs. Actually, if I just did foo bar equals boom, boom, self, because self is always there by default. Bar. There you go. This already is a very, very simple Nix Flake. Let's go into the Flake more so that you understand this. The Nix configuration needs to inherit Poetry. So we're going to make it so we can do that. And I'm actually delete the outputs here for a second. And what we're going to do is we're going to say inputs. Remember, we talked about inputs. So Nix packages.url equals, and then we're going to say GitHub, NixOS, Nix packages, Nix packages / unstable. So now that we have our inputs, let's define our outputs. So what we're going to do is we're going to say self and then Nix packages. So this is actually the input that you define here. So we've now got our Nix packages as our input. Right after the output, what we're going to do is we're going to say let system equals x86_64 Linux packages equals Nix packages dot legacy packages dot, and then we're going to give it a variable of system. Let's also do this in. So let's get to the main meat of the rest of what Cran has presented to us. And I'm going to break it down into three main parts: packages, DevShells, apps. The first one we're going to work on is packages, where you're actually going to build your application. Flake outputs are expecting to have a value called packages. In this case is all of the packages that Nix is going to build. So what I'm going to say is system. And the reason why we say system here is because Nix allows us to build for all all different archetypes. We have x86-64 here. We could build for ARM, whatever. What this means is that this is now the default package in the Flake. So if I was to just do Nix build, I don't have to do any type of targeting. It just knows, okay, well, you set this as the default. And then we're going to say packages. Why? Because we need to utilize a tool to build our package with. And where does that tool exist? In our NixOS packages repository. Packages.poetry to Nix. I need the function in that package .make poetry application. This is using the power of Nix to allow me to lean on the package manager to import an actual application and then use a function inside of that application. So not only can I install a package with the Nix package manager, but I can also use it in code. And then we say project dir equals self. I'm going to do Nix build -L rebuild, but you only need to do Nix build. The only reason why I'm doing -L rebuild is to actually show you what happens when we run it. Okay. So I'm going to hit enter. And there we go. Now, we got a whole bunch of output, and it's going to show us exactly what it's doing here. I should have something that now exists in my folder, and I'm going to do this. I should have a result. Now, you might have asked yourself the question, you built something, but what the did you build, and where the is it? What happens is when you build anything that you use with Nix is added to the Nix store. And you'll see here that this has Nix store in front of it. We're symlinking the result of the build to the Nix store output of that actual build. So what that means is that the data and everything exists in the store now as an actual immutable artifact, and then we can run against it. Now we should actually be able to run the result. So what I should be able to do is just do .result bin start. Oh God, I almost choked on my coffee. We did it. And that, chat, is a completely built Nix package. Listen up. How did we get that start? Right there. So again, this is what we mean when we say that Nix inherits the configuration from poetry. And so now what we're going to do is we're going to create another attribute called DevShells. If we look at the Flake that we currently have, we'll see that we are building only a packages default. So we don't really have any reproducible dev environment yet. And that's a big reason to using Nix as well. So I'm just going to quickly copy and paste in what we have as our definition. And I'm going to go through it really quick. Just like you can have packages with a specific system definition for it, you can do the exact same thing with DevShells. So you could say, all right, on x86-64, I want to have this DevShell with this dependencies. On ARM, I want to have this dev shell with this dependency, so forth and so on. So we're saying that the dev shell for this system is the default. And we want to packages make shell no CC. What is happening is just like the packages poetry to Nix, we also have a packages make shell. We're going to create a shell hook. This is a shell hook that is a command that executes every time you enter the shell. So you can kind of think of this as almost like your MOTD, right? Your message of the day. So once you go into the shell, you should see a welcome to your Nix powered environment, right? And then we can even set environment variables if we need to in that shell. But we can even go one step further and we can add our own packages that we want in this shell that we need. What you're going to notice is we're first evaluating the poetry to Nix make poetry env function. And then we're also getting neofetch. And the point of having neofetch in here is to show you guys that you don't need just project specific things, right? This is a non-Python dependency. So now that we've got that, we do Nix develop. And look, it's doing the exact same thing as the build. There we go. Welcome to your Nix powered development environment. If I do neofetch, I have neofetch. If I open up a brand new shell and I do neofetch, I do not have neofetch here. But because I'm in my dev shell that was built for me, I now have neofetch. And again, I can just leave it, Nix develop, bam, right back in it. Now I'm going to go over one other thing super fast, and that's the app system default. Up until this point, the only way we've been able to run our application is by doing a Nix build and then doing a .result, right? Bin start. This is the only way right now we're really able to run our application. Well, Nix provides us with one more thing to to make it so that that is possible. And that's going to be the apps section. It will actually make it so that we can run the given application that we need directly. Now, you'll notice the pattern is very similar. Just like with DevShells, we're back to that whole, we need to do it for a specific archetype, right? .default, and then look, apps.system default program, self.packages system default build bin yams. Now, this is actually for us going to be bin start. So we're going to change that to start. Once I add this, I don't need to do Nix build anymore, but what I can actually do is Nix run. And now my entry point is integrated into Nix to where I can run that directly as well. You are now officially covered on your very first Flake file. Congratulations. Today was only a taste of the sweetness coming your way in the future, chat. So get hyped. Remember, we stream weekly live on Twitch. We're a variety channel where we do a bunch of different stuff, programming as well as gaming, and that's co-hosted by myself, BG, as well as my good friend and wonderful co-host Atoda. If you ever want to be a part of our community, you're more than welcome to join the Discord. All right, love you guys. Bye.